A Lancaster County farmhouse sits in 90-degree summer heat. No air conditioning unit hums outside. No electric bill climbs past $40 a month. And the family inside is comfortable. They have been for over 150 years, using a hole in the ground. The system is called a root cellar tunnel, or a ground-coupled air shaft. And for most of American history, everyone knew how to build one. Then, sometime in the mid-20th century, the knowledge quietly vanished from mainstream culture. What happened, and whether it was accident or design, is a question more people are starting to ask. The physics are not complicated. Below about 6 feet, the ground temperature in most of North America stays between 50 and 60 degrees Fahrenheit year-round. It does not care what happens above the surface. A 100-degree July afternoon means nothing 4 feet down. That stable temperature is not magic, it is thermal mass. Soil absorbs heat slowly and releases it slowly. The ancient Romans understood this. So did the Persians, who built underground wind catchers called yakshals over 2,000 years ago. The Amish did not invent the principle. They simply refused to abandon it when everyone else did. Here is how the Amish system actually works. A pipe or brick-lined tunnel, typically 6 to 12 inches wide and anywhere from 20 to 60 feet long, runs from outside the house, down below the frost line, and up through the floor of the living space. No fan, no compressor, no refrigerant. The tunnel simply connects the cool ground temperature air to the room above. Warm interior air rises and escapes through a high vent. Cool air draws in from below to replace it. This is a passive convection loop. It runs continuously as long as the temperature difference exists. There are no moving parts, nothing to break, nothing to power. This was not fringe knowledge in early America. Before the Civil War, nearly every farmhouse in the mid-Atlantic and southern states had some version of a root cellar or spring house. Farmers dug shallow tunnels to keep butter, milk, and vegetables cold through summer. Plantation ledgers from Virginia record stone lined cold passages built into kitchen floors. The 1850 edition of the American Agriculturist described ground air cooling as standard practice for any well-built farmhouse. Homesteaders moving west brought the technique with them. Sod houses on the Kansas prairie used the same convective principle, with earthen berms replacing brick tunnels. Then came 1902. Willis Carrier, a 25-year-old engineer in Buffalo, New York, designed the first electrical air conditioning system, originally to control humidity in a Brooklyn printing plant, not to cool people. Within 20 years, department stores were advertising chilled air as a luxury attraction. By the 1930s, movie theaters packed in summer crowds specifically because they had mechanical cooling. The technology was real. It worked, and it was tied to an electric meter, a service contract, and a manufacturer. Every building that converted to mechanical cooling represented a recurring revenue stream. Ground-coupled passive cooling represented none of those things. The post-war housing boom accelerated the shift in ways that are hard to overstate. Between 1945 and 1960, the United States built roughly 30 million new homes. Nearly all of them used slab-and-grade foundations, a flat concrete pad poured directly on the ground, with no basement, no cellar, and no tunnel access to the earth below. The slab foundation was faster, cheaper, and simpler for tract housing developers. It also made passive ground cooling structurally impossible. You cannot retrofit a ground air tunnel into a slab foundation without tearing up the floor. The architecture itself had foreclosed the option. By 1970, window air conditioning units were standard in new American homes. Central HVAC followed. Building codes in southern states began requiring mechanical ventilation in new construction, partly for legitimate air quality reasons, partly because the codes were written by committees that included HVAC industry representatives. The International Energy Conservation Code, which most U.S. jurisdictions follow today, mandates specific mechanical ventilation standards that passive systems struggle to formally satisfy without additional testing and certification. A ground tunnel that has cooled a farmhouse for 100 years does not come with a manufacturer's data sheet. Without that sheet, a building inspector in most counties cannot approve it. The Amish communities of Pennsylvania, Ohio, and Indiana were largely insulated from this regulatory drift. Their districts operate under religious exemption principles that limit grid electricity dependence. They continued building root cellars, spring houses, and ground air tunnels throughout the 20th century, not as a political statement, but because the systems worked and the community knowledge was intact. Today, Lancaster County alone has an estimated several thousand active Amish homesteads using some form of passive ground cooling. Visitors consistently report that stepping into these homes in July feels like entering a different climate. The indoor temperature runs 10 to 15 degrees cooler than outside without any electrical input. The construction of a basic ground air tunnel requires no specialized skills. You need a trench, a length of 4-inch perforated PVC or terracotta pipe, gravel, and a connection point at the floor. The trench runs from a shaded exterior location, north or east side of the house, ideally under tree cover down to 4 feet below grade, then up through the foundation wall or floor. The exterior inlet gets a mesh screen to block insects and small animals. The interior outlet gets a simple gravity flap to prevent backdraft. Total material cost in most regions runs under $200. Labor, if you dig by hand over a weekend, is $0. The performance ceiling is real and worth being honest about. A ground tunnel is not central air conditioning. On an extreme humidity day in Georgia or Louisiana, the system pulls in outdoor air that is already carrying significant moisture. Condensation inside the pipe can become a problem if the design does not account for drainage. The cooling effect in high humidity climates is typically 8 to 12 degrees rather than 15 to 20. Still useful, still zero cost to operate, but not a complete solution in all climates without a dehumidification stage added at the interior outlet. The Amish traditionally pair the tunnel with a root cellar buffer room, a small stone-walled antechamber that absorbs additional moisture before air enters the living space. There is a modern engineering equivalent that has gained quiet traction in Europe, the earth-air heat exchanger, sometimes called an earth tube or Canadian well. Architects in Germany and Switzerland began formally testing these systems in the 1970s. By the 1990s, the Passive House standard, Germany's ultra-low energy building certification, had incorporated earth tube preconditioning as an approved component. German research at the Fraunhofer Institute documented cooling reductions of up to 10 degrees Celsius in summer trials. The system these researchers were publishing peer-reviewed papers about was, structurally, what Amish builders had been putting in the ground for generations. The innovation was the documentation, not the concept. The legal picture in the United States is genuinely complicated, and this is where the story gets interesting. There is no federal law banning ground air tunnels. The restrictions live at the county and municipal level, buried inside residential building codes. In roughly 35 states, installing an unlisted ventilation system in a new construction home requires a variance, a formal exemption from the standard mechanical ventilation requirement. Variances are granted routinely for solar and geothermal systems because those have certified manufacturers, lobbying associations, and tax incentive programs behind them. A hand-dug Amish tunnel has none of those things. It is not technically illegal. It is just impossible to get approved through the standard process. But something has shifted in the last decade. Rising electricity costs have pushed average American household cooling bills past $1,100 a year in southern states. The 2021 Pacific Northwest heat dome killed grid infrastructure across 3 states in 72 hours. Climate anxiety about power reliability is no longer theoretical. Suddenly, YouTube channels documenting Amish building methods are getting millions of views. Homesteading communities in Tennessee and Texas are successfully applying for variances by citing the Passive House earth tube data as technical backing. Some counties in Arizona and New Mexico have added earth tube provisions directly into their residential code updates. The knowledge is not lost. It just needs a path back. There is a broader pattern worth sitting with here. Passive cooling is not the only pre-industrial technology that was functionally erased by the standardization of the 20th century. Earthen plaster, lime mortar, rainwater catchment, timber framing with no adhesives, all of these face the same regulatory friction. They are old. They generate no recurring revenue. And they require a building inspector to exercise judgment rather than check a box. The Amish kept these techniques alive, not through activism, but through insular continuity. The question is whether mainstream culture can recover the knowledge before the last practitioners who carry it in their hands are gone. A ground tunnel dug this summer will still be cooling a house in 100 years. The PVC will outlast the family that installs it. The physics will not change. Central air conditioning has been the default American assumption for about 60 years. Before that, for all of recorded human history, the answer to summer heat was the same. Go underground, use the earth. That knowledge did not disappear because it stopped working. It disappeared because it stopped being profitable. Whether that matters enough to act on is a decision every homeowner gets to make for themselves. So here is the real question. If the building code in your county allowed it tomorrow, would you put one in?